Hello everyone, myself Pavni Raj from SBC Department of CSCDS. So the subject is mathematics and the topic to be discussed over in this section is joint probability distribution of two discrete random variables and their covariance. Let us look over the introduction part. Joint probability distribution of two discrete random variables, definition and the importance of an covariance, and the overview of a presentation agenda. So two discrete random variables may be like the joint probability distributions, marginal probability distributions, conditional probability distribution, and the independence. Let us look over the joint probability distribution. Definition is probability distribution of two discrete random variables occurring simultaneously is referred as a joint probability distribution. Specifies the probability of each possible combination of an outcomes. So represented by the joint probability of a mass function PMF. Joint probability distribution of two random variables is equal to an bivariate probability distribution. And the notation and the formula is given over in this slide, where the P of a capital X is equal to small x, where capital Y is equal to small y. That denotes that the joint probability of a capital X is equal to a small x, and the capital Y is equal to a small y. And let us take an example of an to consider by considering two dice rolls where x represents the outcome of a first roll and where the y represents the representation of a second roll. This is a best example for a joint probability distribution. And let us look over the covariance. Measure how to it means that to measure how two random variables vary together and captures the linear relationship between those two variables, and also provides the insight into a direction and the strength of the relationship. Calculation for the covariance is over given in this slide, where E of x and the E of y represents the expected values of an x and the y respectively, and the interpretation of a covariance, where the positive covariance variables tend to increase or decrease together. Negative covariance variables tend to move in opposite direction, with the covariance value of 0 non-linear relationship between the variables. Properties of a covariance. Covariance of an x and x is equal to a variable of x. Covariance of a variable with itself is it's a variance, where covariance of an x comma y is equal to a covariance of y comma x, such that covariance is an symmetric. If covariance of an ax comma y is equal to an a. Covariance matrix, where a matrix representation of any covariance between the multiple variables, diagnostic elements, variances of any individual variables, and the off-diagonal elements are covariances between the pairs of variables. So let us go for the conclusion. So over in this section, we recap the key points and discuss over through the presentation and the importance of a joint probability distribution and the covariance statistical analysis. Also encourage for the further exploration and the application in the real world scenarios. Thank you.